Welcome to video 2 of my math series. This is common knowledge, basically calculus information that I think everybody should know. So we figured out the different formulas for integrals, and now we're going to apply them and to basically say that the integral of a function is the opposite of its derivative. And the way you would write that is which one do we want on the outside? Let's say the integral, you want the derivative on the outside. So the derivative of the integral of a function is the same as the function itself. How are we going to prove that? Well, my teacher always told me, use the definition. So the definition, we're going to define these. The dx of a function is the same as the limit as h approaches 0 of f of x plus h minus f of x all over h and we want to say that the integral of a function, I'm going to use the summation symbol, so I have to bring this down a little, as h approaches 0, I equals 0, x minus c all over h, f of c plus ih times h. This is the general form. We're going to be using the general form to prove this formula. Okay, now how are we going to do this? Basically, you want to plug this into this. So you want to put this into here so that this goes here. But if you notice, it shows up twice, divided by h. So this goes here, and this goes here. This is going to be big. Okay, let's start down here. Limit as h approaches 0 of the summation I equals 0 x plus h minus c all over h f of c plus ih times h minus summation I equals 0 of x minus c all over h f of c plus ih times h, and all this is divided by h. So already we can cancel out these h's. Let's get rid of that right away. What else? What other patterns do we notice? What do we notice? Well, this is kind of hard to work with. Somebody might just want to give up and say, well, I just leave it the way it is. But guess what we can do? This can be collapsed so that x plus h minus c all over h is the same as x minus c over h plus h over h, which is 1, x minus c over h plus 1. Okay. Summation I equals 0. And you want the limit as h approaches 0. F of c plus ih. And we got rid of the h's. Minus. And what do we have over here? X minus c all over h. Summation I equals 0. F of c plus ih. Okay. What else can we do here? Well, this is the next increment up. So we can bring this down. This goes into your I. We can bring this down. We can say f of c plus, and your I is going to be substituted by this last term, h plus 1 times h. Only the I gets substituted, and this is all, and this is plus, and I guess I have to write this whole thing out. So we have, now we're going to subtract 1, and the reason we subtract 1 is it was because we brought down the last term. So now we want the next to last term, so that's just basically the last term minus 1, which is this. So you have x minus c all over h, summation I equals 0, f of c plus ih, and we're going to say minus x minus c all over h, summation I equals 0, f of c plus ih. So we brought down the last term, and guess what? These two are identical. So this plus this goes to 0. So now we're only dealing with that very last term. What can we do here? We want the limit as h approaches 0. Okay, so bring that down. As h approaches 0 of f of c plus, let's distribute the h, x minus c plus h and since this is now down, these two cancel, and because you want the limit as this goes to 0, let it go to 0 and you're left with f of x, which is what we wanted. And like a true mathematician, you end your proofs with QED.